Good morning to all. Greetings. This is Dr. P. Ravindra Kumar. So, in the last class, we have discussed the what is meant by a system, types of a system. Uh, so, once again, recapitulating the last class points. The types of a system. It is a closed system, open system, and isolated system. Apart from that one, we have discussed the homogeneous and heterogeneous system and its basic examples. And in that one, when you take the system and that system is external to the system, surroundings is there, and the boundary which is going to separate the system and the surroundings, the classification of a boundary. So for a closed system, the boundaries, it is a closed in a boundary, there is a fixed boundary is there, and moving boundary is there in closed system, whereas in open system, there is a real boundary and an imaginary boundary is there. And next one is we have discussed the control volume. We have discussed the control volume, and in a control volume and in a control volume, the main important thing is for open system, that is how the control volume, that is the fixed volume is there, and how the mass is entering and how the mass is leaving. So that particular things we have discussed in the last class. So here, if you just observe that the in a closed system, the mass is a fixed one, whereas in open system, a region through which matter flows is fixed. So the fixed region in space is called control volume. The control volume may be either stationary or moving at constant velocity. So, the surface of a control volume, the surface of a control volume, you can call it as a control surface. Now, you should have to identify the what is going to happen onto the control surface, right? So, onto the control surface, this mass, work, and heat transfer may occur across the control surface. If no mass transfer occurs across the control surface, then the control volume becomes identical with the closed system. But if both the position and the size of the control volume change, then the control volume is going to be equivalent to the open system. So the control volume concept is more useful. Control volume is more useful in the analysis of a fluid flow. So thus, in a way, open system is called as a control volume. Open system is called as a control volume. Next one is the what are the basic differences, that is differentiate the control mass and control volume. So this is also one of the topic we need to discuss. So the control mass, generally the control mass is going to be applied for a closed system. Next, whereas for control volume, it is for open system. So the control mass, it is applicable for the non-flow process, whereas the open system, that is control volume, applied it for the flow process. So in this case, in a control mass, matter does not cross the boundary, whereas in this case, matter flows continuously in and out. Heat and work crosses the boundary, whereas in open system, heat and work across the control surface. See, this is important. Next, in a control mass, focuses a definite quantity of matter. Matter is enclosed by a boundary. But in an open system, focuses definite volume, and this volume is enclosed by the control surface. So the shape of the boundary may change, but fixed. Here, the control volume need not be the stationary, right? So this is all about the difference or the differentiate between a control mass and control volume. So the question is going to appear the differentiate the control mass and control volume techniques. So that is the point. And now I am going to go for the another PowerPoint presentation. Yes. So now the second class. In the second class, I'm going to discuss this macroscopic and microscopic points, macroscopic and microscopic viewpoints, concept of a continuum. So today I'm going to discuss the macroscopic. Today I'm going to discuss the macroscopic and microscopic viewpoints, concept of a continuum, and thermodynamic equilibrium. Thermodynamic equilibrium. So this is what I am going to cover. So the outcome from this particular topic is differentiate the macroscopic and microscopic points. What is the difference between continuous and continuum? Thermodynamic and thermal equilibrium. Thermodynamic and thermal equilibrium. So these are the topics I'm going to discuss for today's class. Now, coming to the macroscopic approach, here the difference what you need to find out is that, say suppose if you take 1 meter cubed of a container or 5 meter cubed of a container, and in a 5 meter cubed of a container, how many air particles you are going to fill up in a 5 meter cubed of a container in atmospheric state condition. Say suppose if you carry the same 5 meter cubed of a container to the higher altitudes, right? So the higher altitude means where the ozone layer, stratosphere, ionosphere. So in that case, how many air particles are going to be filled up in 5 meter cubed? So that is what the importance of this macroscopic approach and the importance of this microscopic approach you are going to analyze, or you are going to discuss in this particular point. So here the macroscopic, observe this macroscopic means consider a certain amount of a gas in a cylindrical container. Certain amount of a gas in a cylindrical container. The volume V can be measured by measuring the diameter and height of a cylinder. The pressure of the gas can be measured by a pressure gauge. The temperature of the gas can be measured by a thermometer. So, the state of a gas can be specified by pressure, volume, and temperature. The values of these variables are space average, characteristics of the properties of a gas under consideration. So, this you can also call it as a classical thermodynamics. So, we often use this macroscopic in classical thermodynamics. So, the macroscopic approach has the following features. So, one thing is that here the structure of the matter is not considered in a macroscopic. Next, moreover, the few variables are used to describe the state of a matter under consideration. So, the values of these variables are measurable following the available techniques. Following the available techniques, right? So, that points you have to observe. Next, there is a microscopic approach. So, in a microscopic approach, the microscopic approach, you can also call it as a statistical thermodynamics. So the statistical thermodynamics means, a gas can be considered as an assemblage of large number of particles, each of which moves randomly but with independent velocity. So the state of each particle, this can be specified in terms of the position coordinates and the momentum components. So if we consider a gas occupying a volume of 1 centimeter cubed at ambient pressure and temperature, the number of particles present in it is of the order of 10 to the power of 20. 10 to the power of 20. So the same number of position of coordinates and momentum components are needed to specify the state of a gas. So the microscopic approach, finally you can summarize it as a knowledge of molecular structure. Knowledge of molecular structure of the matter under consideration is essential. Large number of variables are needed for complete specification. for complete specification. So what is the question? Differentiate between a macroscopic approach and microscopic approach. You can also get the question onto this one. So that here in a macroscopic approach, the attention is focused on certain quantity of matter without considering the activity occurred at the molecular level. But matter constituting a system is considered to comprise many number of discrete particles called molecules. So here in a macroscopic approach, few properties are required to describe the state of a system, whereas large number of variables are required to describe the state of a system such as position, kinetic energy, velocity, PVT, etc. So it is very difficult to measure these quantities with available instruments. The expansion of gases in IC engines. So that is the macroscopic approach. But the kinetic theory of gases you have to consider as a microscopic approach. So in this macroscopic requires simple mathematical formula to analyze the system, whereas in this requires advanced statistical and mathematical formula to analyze the system. So this it is known as the classical thermodynamics. This is known as a statistical thermodynamics. So these things you have to observe. Next, the concept of a continuum. What is meant by a concept of a continuum? So here, two things that you have to observe. So that is from the macroscopic viewpoint, we are concerned with volumes which are very large compared to the molecular dimensions. So even a very small volume of a substance is assumed to contain such many molecules. So disregarding the behavior of individual molecules, so matter is treated as a continuous. So in most of the engineering applications, the assumption of a continuum is valid and convenient. So in thermodynamics, matter is treated as a continuous. So the concept of continuum is only a convenient assumption, but it loses its validity when the matter is treated as microscopically. So now I think you have got the idea onto this microscopic and macroscopic approach. Say for example, in space flights, high vacuum technology, rockets, right? So in this case, the concept of continuum is not valid. So in applied thermodynamics, we adopt largely the macroscopic study of the matter only, right? So this is the concept of a continuum. Next, here, if you observe the diagrammatic sketch of this one, the x-axis line. So the x-axis line is the delta V. The x-axis line is the delta V. Y-axis line is delta M by delta V. So now here you observe the domain of molecular effects are going to be here. The domain of a continuum is going to be existed over here. So in this case, what you have to understand is that the concept of a continuum is going to lose its validity. That is when mean free path of the molecule approaches the order of magnitude of dimensions of the vessel, as for instance in highly rarefied gases encountered in high vacuum technology, or in rocket flights at high altitudes and in electron tube. So in most of the engineering applications, however, the assumption of a continuum is valid and convenient and goes hand in hand with the macroscopic point of view. Thank you.